The correspondence between Pascal and Fermat that led to probability theory. Do you know how probability began? Today, we use probability in many fields, including weather forecasting, insurance, economics, and artificial intelligence. Surprisingly, probability theory began with gambling. Mathematicians first started studying probability because of games that people played for money. In the 17th century, dice games were extremely popular. However, gamblers faced a puzzling question. When rolling 3 dice, which occurs more often? A total of 9 or a total of 10? At first glance, the two seem equally likely. Which do you think occurs more often? Galileo Galilei studied this problem. He discovered that when counting outcomes, the 3 dice must be treated as distinct. As a result, he showed that the sum of 10 occurs more often than the sum of 9. Gambling problems thus became an important subject of mathematical research. Around the same time, 2 brilliant French mathematicians, Blaise Pascal and Pierre de Fermat, exchanged letters and studied probability. Their research also began with gambling. A nobleman who enjoyed gambling, Chevalier de Marais, asked Pascal a series of questions, and Pascal discussed them with Fermat. The most famous of these is the problem of points. A and B began a game, each wagering 32 pistoles, a Spanish gold coin of the time. The first player to score 3 points would win all 64 pistoles. However, the game had to stop when A had 2 points and B had 1 point. How should they divide the money fairly? Pascal considered the games that remained. If A won the next game, A would become the champion immediately. If B won, the score would become 2-2, and they would need another game to decide the winner. After examining each possibility step by step, he concluded that a fair division was 48 pistoles for A and 16 pistoles for B. Fermat used a slightly different method. He assumed that at most 2 more games would be played and listed all possible outcomes. There were 4 possible results. In 3 of them, A became the final winner. In only 1, B won. Therefore, the probability that A would become the champion was 3/4, while B's probability was 1/4. So, if they divide the 64 pistoles in proportion to their chances of winning, A receives 48 pistoles, and B receives 16 pistoles. Although they used different methods, the 2 mathematicians reached the same answer. Which method seems easier to understand for you? De Marais did not stop there. He posed another interesting problem. In the first game, a player rolls 1 die 4 times and wins if a 6 appears at least once. In the second game, a player rolls 2 dice 24 times and wins if a 6 appears at least once. De Marais thought the 2 games would have the same chance of winning. But when he actually played them, he lost money more often in the second game. Why did this happen? Many people mistakenly believe that previous results affect the next result. But dice have no memory. No matter what happened before, each new result is independent. We call this an independent event. If we calculate the probabilities, the first game has a winning chance of about 50.8%, while the second game has a winning chance of about 49.1%. The difference is very small, but the first game is slightly more favorable. De Marais did not expect this small difference. This event holds great significance in the history of mathematics. The letters exchanged between Pascal and Fermat became the starting point of modern probability theory. Today, we use probability to forecast the weather, assess disease risk, and build artificial intelligence. Yet, isn't it remarkable that it all began with a gambler's question? Perhaps mathematical progress does not begin in a grand laboratory, but with a simple curiosity. Which game offers the better odds? Remember that a small question from your everyday life can lead to a new discovery in the future.